back, and we're joined today with Dr. Loomis. We have a guest star.
Yay!
Isn't that right,
Our
Mr.
first
Miller?
guest star. We're going to be really nice so she comes back.
Okay.
Mr. Miller has been pushing hard, and finally someone kind of caved. So, Dr. Loomis, welcome.
Thank you.
All right, and today we are going to start with inverse normal curve.
Awesome.
But first, we're going to let Dr. Loomis tell us how she uses stats and every day in psychology. Okay.
Dr. Loomis,
So,
just to start, not everyone may know who you are. Could you explain
Okay.
Yeah.
what
that
you
would
do
be-
here for me?
So I'm the school psychologist here, and I have a couple different hats I wear, but one of them is definitely using the bell curve and stats in my day-to-day job because number of kids who are in our special ed program and in order to access services, especially if they're going off to college, is to look at how they're performing compared to others and what their educational needs might be.
Okay,
Very good.
sounds good.
So people in AP psychology, check this out. This is it in action.
Yes, it is.
There you go.
Okay.
All right, so our first slide. How do we?
Okay, so this first slide just shows you what the bell curve looks like. We're going to see if the pen will work. So this is kind of just a man-made construct to say how we could space people out and how they would perform. And if we look at our second slide, which is the way I like to use it because it seems a little more realistic. Go ahead.
Okay.
This is our 100 people chart.
Oh, wow.
And so we have 100 people in here. And theoretically, if we took 100 people and I were to give them a test, what would happen is, let me see if I can get the pen to work, about 68% of you would fall, whoops, this whole middle part here.
That was a big number today. That number 68 came up a lot.
Yes, it did.
Okay, so there's 68 little faces in here.
Oh, that's
So
cool.
if I were to just randomly choose 100 kids in our school and I was giving them an IQ test, chances are about 68 out of those 100 would fall within this area. Then we'd have some of you who would fall all the way up here at the upper extreme. So we're talking a couple standard deviations above the norm. So this is your norm
AP
here.
stats students.
Yeah.
I recognize
Okay.
a few of them.
So yes, these would be your AP students. And then we have students who are just in that high average range. And so we use these classification labels to talk about it. And then we have
Pretty
students here, there we go, who are just your average, and there's nothing wrong with average.
Nope.
And then we have students who might be a little bit lower along the scale. Now for these students, those might be students that we're going to give more specialized supports to. And so they'll fall, here's your mean of 100. And then this would be, one standard deviation is actually 15 points, so it's about 85. And then if we go down to 70, we're hitting about our second standard deviation. So
Okay.
kids who are here, chances are a lot of these students who are at the lower end, they may not necessarily be here at Foreman because they're receiving more intensive specialized supports. So
Okay.
we don't really see those kids because they're kids who are really, they're learning a lot of functional skills, so we don't get to see them. But the students who are here, we have lots of kids who are pretty average, but sometimes they might need supports because your brain works one way and maybe you just need a little more time to process. So when I do an IQ test, and you guys are going to talk about that in psychology for sure, is that we're looking at how do you go about taking information in, how do you process it, how do you spit it back out. And sometimes when the brain doesn't do that as well, then we say, what can we do outside of you to help support that so you can still show everyone how smart you really are.
All right.
So this is a way of addressing what everyone needs, a way of finding out what they need and how to give them the support they need.
That's what I use with like the testing that I do. So I look at how do you do in terms of your potential, and then where are you at academically, and if there's a mismatch, why is there that mismatch? So we have a number of kids, you might know some who are getting additional time when they take the ACT test. Give you the extra time, you can definitely show what you know. But if I ask you to do it in that limited amount of time, you can't show your maximum. So that would be one example.
Okay.
I'll take it
Okay.
as long as you don't tell my wife the result.
Okay. So this one here, the chart that you're looking at here, this is from the back of one of the textbooks that I actually had when I went through my training program, and now I use with my graduate students. And what you see up here are your different IQ tests. This one is the Wechsler. That's probably the most famous one, or the one that's best known in our system. And what they do is they take the standard scores on the IQ test and they give it a verbal classification. So you've got your average range if you score between 90 to 100. If you score between 80 to 89, low average, high average, 110 to 119. And again, I'm pretty sure that for the psych students, they end up doing like an online IQ tests. So you'll get some of these types of results with classifications.
Dr. Loomis,
Nice.
how is this related to like the idea of grading on a curve?
Um,
Is it related? Because it's kind of comparing you to the group, right?
right.
So
And
then
so,
we have the idea it's comparing to the mean IQ
right.
score, right?
And so, like when you do grading on the curve, you could have someone who may not, if you take all the scores within that particular class and then bring them into your bell curve. So a student could end up, maybe your score could be a perfect score of 100, but if the highest score the student had in your class was 89, then that becomes the top part of your scoring.
So it's a comparison to the group.
Comparison to the group. So
Okay.
what we're doing is you find your mean score and then you work your standard deviation out from there and then
Okay.
you compare them.
All right, very good.
Okay.
Okay?
All right.
Back to business.
Yeah, we're gonna have to get back to
Okay.
business
Thank
now.
you,
You guys
Dr.
are gonna do
Loomis.
some
You're
work.
welcome.
All
Enjoy
right.
the rest of class.
Yeah, we'll
Our first guest.
pass over the
Yay,
pen.
it was such an honor. Thank you.
Thank you.
You're a star now. Dr. Loomis, you're a star anyway.
Oh, you guys are so sweet.
All right.
Okay.
Now we are getting back to the curve.
Back
Today,
to the curve, man.
yeah,
That sounds pretty cool. Back to the curve.
it's like a Weezer song.
Yeah.
Back to the curve. All right, whatever. Anyway,
Stick the man.
so now we're going to look at the other way around. We're going to give you the average height of players and the standard deviation, and we're going to tell you. Here we're going to
Something.
ask again. What? This is a review. Sorry, Dr. Lynn's going to be all flustered. All right. So first, we're going to review and ask what percent of the players would lie between 65.9 and 70 inches. So here I'll draw my bell curve. One that's extremely slanted. Ooh, yeah, kind of a fat bell curve. Anyway, so we have our mean right here in the middle. Okay, and that was 68.
Very good.
Okay, and I want to know 65.9 and 70. Well,
That's kind of weird numbers, but let's see how
so
it goes.
We'll go probably
Grab the calculator here.
down here and probably about here and
So we want the percent in between 65.9 and 70.1.
right. So that's probably going to be in this area. So Mr. Miller, using our norm CDF on our calculator.
Got my lower, getting my upper. I'll make sure I get some lowers and uppers in every day. 68 and standard deviation 2.1.
Yep. Let's paste that baby.
Wow, this is weird.
We
I
get
got 68
68%. Now,
Uh-oh.
wait a minute. There probably was a faster way to do this, wasn't there?
68%. That's right. That seems very familiar.
Because, yeah, I think I know what that meant.
Oh, it turns out that this must be one standard deviation down and one standard deviation above.
Right.
I didn't kind of recognize that at first, but if we do 68 minus 2.1, then that's the lower limit, the lower cutoff
which is
value.
65.9. And
And then if we do
exactly that.
68 plus 2.1,
we get 70.1.
so I didn't realize it at the time, but we could use the empirical rule to do this. It was just asking what percent were within one standard deviation.
But it is nice that the calculator backs us up on that.
True. So we always got normal CDF, but if we recognize a situation like this, then we can just use the empirical formula. All right,
Right.
I'm gonna be looking this time.
Okay. So now here we have our bell curve again.
Ooh.
Okay. Yeah, different bell curve. You know, it's the same data. All right, here we got our 68. Okay, so now we want to know what percent of the players are over 71. Well, that doesn't seem. Our 70.1 was one standard deviation away, so this looks like little under 1.5 away.
Yeah. So this one isn't
No,
an
it's
empirical formula.
right. There's no fast way to do this because we want the area under here.
Okay. So
We want greater than 71.
all right, Lewis, help me out here.
All right, norm
so
CDF.
lower limit is what?
71.
Upper.
Upper limit would be like infinity, so maybe like 100,000,
100
10 to the
billion.
99.
Okay. 68, 2.1.
Yep.
We get 0.076, so 7.6%.
7.6%.
So the moral of the story is normal CDF always works, but there are some problems if they only involve even multiple or just multiples of the standard deviation. We can use empirical rule.
Right.
Okay. The empirical rule helps us understand the normal curve, though, so that's why it's good.
Okay, so that was review.
This is
All
new.
right, here's the new stuff. Okay, so now we want to know is we're given the percentile. So even Dr. Loomis was talking about percentiles when they were doing the IQ score.
Mm-hmm.
So I know, and you guys have gotten that when you got your ACT results back. They told you what percentile you fall in. Okay,
Yeah, what does that mean?
We want to be able to use that percentile to find what our score is.
So
right?
we're asking,
so what our height is.
We're asking for a cutoff value. So
Yes.
this is not asking for a percent, it's going backwards. So we want to know what data value has 70% of the rest of the data below it.
Right.
So that's the idea of percentile. 70th percentile is the height that would be greater than 70% of the others.
Right.
Let's do a diagram.
Okay, so basically, so you have here's our bell curve. All right, our normal distribution.
Ooh, I like that one.
Yeah, I'm actually getting better on my bell
put in
curves.
the mean.
All
So
right, we put in our
always
mean.
include the mean and standard deviation.
Here's our 6. Here's our
Those
standard deviation.
2.1.
2.1. Okay.
So 70, the 70th percentile is more than half. So we know it's somewhere on the right of the mean.
Yeah, we know 68 is is in here. I mean, so we're
Yeah.
probably like the majority of it. You guys could probably like ballpark what 70th percentile is, but we want to know what that cutoff value is.
So let's draw a line.
Okay.
And where we just estimate where 70% is and put X down here on the bottom. That's what we want, the data
Right.
value. And could you shade in the area on the left? And let's mark this as 70%. So this is going backwards. We know the percent. We want to know what value of X has 70% below it.
Right.
Well, that's the other normal command curve that we need.
Yes, we want to do now the inverse.
Yeah,
Okay.
so inverse is kind of like going backwards. So we're going to enter the percent we want, and it's going to give us the data value.
All right, and we kind of gave you some help down here. We showed you what your calculator is going to look at. Now this is if you were lucky enough to have one of the updated calculators, which we're going to try and get everybody in a second.
No problem.
If you don't, we'll walk you through what yours is going to look like anyway. All of you will go to second distribution.
Yes.
Okay, and we're going to hit the third one right here, inverse norm. Inv
Ooh.
norm.
Something new.
Okay,
I see exactly what the
In-
second screen says.
norm. Okay, so now it's going to ask you for the area under the curve. That's our 70%, but we
Yeah.
need that as a decimal.
Yeah, and it's always area to the left of the value. We'll talk more about that later, but
Right.
the
So
calculator only handles area to the left of a value.
70 percentile, remember, is 0.7. Okay, so you know, and those with you with not the function, you just type in 0.7, and what's the area first?
And then put a comma. Then put you got to tell it what normal curve we're using.
Okay.
So enter 68 for the mean,
Right, 68 for the mean,
and 2.1 for the standard deviation.
and 2.1.
And we'll paste. And I get 69.1.
69.1.
So 69.1 would be 5 feet.
5 feet 9 inches.
And plus 0.1 inch, right?
Right,
Yeah,
I mean,
so about
but-
5'9".
Yeah, I mean, there's some change there, but mostly when you go
Yeah.
to the doctor, you got 5.9.
So 5.9, that means 70% of volleyball players are shorter than them, and 30% are taller than them.
Right.
Okay.
So if they gave you a test score back and they said you're in the 70th percentile, you're doing pretty well above the average. There's
Good.
70% of the people below you.
So it's really easy. If we know that data has a normal distribution, it's easy to find the percentiles this way.
Yeah.
All right, we're going to do something.
Okay. Let's do a couple more.
Okay, 34th percentile.
All right.
So you want to write down the command?
Yeah.
For
Inv
those?
norm. All right. Then we want our, so it'd be 0.34 is our
Yeah.
percent.
And if you have the updated calculator, then you just enter that at 0.34 as area.
Okay. There's the 68, and there's my 2.1.
Paste.
What's that give us?
67.1. So that'd be 5'7".
67.1. So that's kind of interesting. There's 30, that 2 inches is 30% of the data.
Yeah. That's all right. So they're all kind of...
Yeah, everyone's
The
pretty much
spread's
the
not very
same
nice.
size. Which would make
Oh,
sense.
wait.
That's the middle part.
What does Q1 have to do with normal curves? Q1 is the...
It's the 25th percentile.
Yeah, so
Q1
we know that
is the
25% of the data is
Oops.
below Q1. So we can find Q1 and Q3 for normal distributions. And, of course, we could find the IQR.
Right. So Q1's the
Ooh.
25th percentile.
It
So
is,
I'm not going to type all that in.
it is
yeah.
all coming together, man.
So let's see if we can do it really fast.
All right.
0.25.
All right. Got other videos to watch, I understand.
Exactly.
66.6.
66.6%.
And then second
Q3
distribution.
is 75% of our data, because Q2 would, of course, be the median, which would be 50%. of our data.
Yeah. All right. Boom. 69.4.
69.4.
But these aren't percents. Could you scratch out the percent?
I'm sorry. Yeah, my
these
bad.
are
What am I
inches.
doing?
So these are
See,
data values.
I'm getting percent-y with these, and
I
I'm
know.
just like, I'm all
So,
about percents.
20.
Yes.
So the
These
25th
are
percentile.
inches.
Yeah.
Inches.
Very good.
Let's have the right.
So these are data values we're finding. Now, we can find the IQR by subtracting Q3 minus Q1.
Yep.
So
Which we
we
should all
can
be
find the
experts at.
IQR for a normal model also. Usually we're going to use standard deviation to describe the spread of a bell-shaped data,
Yeah.
but we can compute the IQR too.
So 2.8.
Man.
Back me up on that, Chief.
I'm working with a genius here. It is 2.8. Smooth.
All right. Here we go. Oh, already that time. Journal assignment time.
Yes.
I feel Dr. Loomis did most of the talking today.
We got to get it back more often. All right, so the scores of players for the final round of the U.S. Open Golf Tournament has mean 69.6. Okay. And standard deviation 1.6.
Okay.
So assuming the data has a normal distribution, find the 56th percentile, the 25th percentile, 75th. You know this is going somewhere. If we use Q1 and Q3, you know what's this headed for.
Yeah, we want that IQR.
Gotta
We
have
want to
it.
know what's in the difference.
I know.
All right, so we'll see you guys tomorrow.